Good day to all. This is Remya Rose, Assistant Professor from Department of Artificial Intelligence and Machine Learning, RMD Engineering College. This video we are going to see about two-phase locking protocol. So first let me tell you why we go for two-phase locking protocol. By the word protocol, you understand that protocol is all about set of rules that is to be followed. So we are going to follow certain locking rules in concurrency issues, during concurrency issues. See, in the previous video we have seen about different types of schedules, in which we saw about non-serial schedules. I told you when in a schedule the different transactions are not going to wait for the other transaction to complete and they concurrently keep executing. There are chances for concurrency issues, like a transaction tries to read an operation which is not properly written and committed. So in such situation, there will be certain concurrency issues like false read, wrong information being updated in database, and so on. So to overcome the concurrency issues, we are going on into lock-based protocol. So the most important or the most popularly used lock-based protocol is the two-phase locking protocol. In this video, we are going to see in detail about the two-phase locking protocol. So protocol is going to be some set of rules that is to be followed. Since it is a log-based protocol, we are going to keep certain rules and regulation regarding the logs. Log is nothing but a control we keep on certain data item so that the data item could be safely read and written by a transaction. Now, a log could be of two types, or a log could be obtained in two mode. You call it as exclusive mode, other one is the shared mode. So lock X denotes exclusive lock and lock S denotes a shared lock. What is actually exclusive and shared lock is, suppose a transaction is locking data item with exclusive mode of lock, then the transaction can perform read and write with respect to that particular data. But if the same transaction is going to lock that particular data item in a shared mode, the transaction will be allowed only to perform read operation with that particular data item. That you call it as exclusive lock as well as shared lock. Now all these lock requests are made to the concurrency control manager, and the manager is going to either grant or they are going to not grant the locks. So say for example, we have 3 schedules and all the 3 schedules are going to be concurrently executing. Now these 3 schedules can request for a lock on certain data item. So suppose T1 is granted a lock on certain data item, then when T2 is trying to request the same lock, T2 will be put to wait till T1 releases the lock. So when a data item is locked by a transaction, the same data item could be read or written by other transaction only when the lock is released by the already locked transaction. So now we'll see about the lock-based protocol. How the protocol works is simple. It works on the principle lock as well as unlock. Lock data, unlock data. So different transaction will be sending requests to the transaction manager or the concurrency control manager requesting for a lock, and the manager will analyze the lock and see whether it is compatible in the sense if it is much needed for that particular transaction. On the priority basis, the transaction manager or the concurrency control manager will either release the lock, or you call it as granting the lock, or they will deny the lock. Suppose if it is granted, the transaction will proceed with the same data item. If suppose it is denying, the transaction will wait until the lock is granted. That is how the locking protocol works. And here we have an example where there is a transaction T2. T2 has locked data item A on a shared mode, so it could only read. And it is unlocking it. Now since it is unlocked, now A could be locked by some other transaction, say T3 or T1 and so on. Now after releasing the lock on A, the same transaction T2 is locking data item B. Again it is locking data item B in a shared manner. So it could only read, and it is unlocking. So suppose if same transaction T2 has locked this data item A on exclusive mode, we will have the statement lock X of A here. So we can have read A as well as write A over here. But whatever be the mode of lock you obtain, when there is a lock, only after having an unlock statement with this particular transaction, this data item could be read by or the data item could be locked by some other transaction. So this is how the two-phase locking protocol work, or the normal locking protocol work. But when you call the locking protocol two phases, you have got two different phases with this locking. One is the growing phase, other one is the shrinking phase. Growing phase is a phase in which the transaction keep obtaining locks one after the other. Transaction may not release locks at all. They keep only obtaining locks, or they keep only requesting for lock. That way you call it as a growing phase. Shrinking phase is a phase in which the schedules or the transaction keep on releasing the locks and they are not trying to obtain any new locks. That you call it as the shrinking phase. So either in a growing phase your transactions will work, or in a shrinking phase the transaction is going to go. But whatever it is, the general principle over the protocol is that when a transaction wants to perform a read or a write on a data item, it has to request a lock, which could be a shared or an exclusive lock. Only after the lock is granted by the concurrency control manager, the transaction can proceed with the read write operation on that particular data item. So now I told you we have shared mode and exclusive mode of locking. Now the locks could be converted. The lock types could be converted. So when you convert a lock from shared to exclusive mode, you call it as upgrade mode. So a lock could be converted from S to lock X, or shared mode to unshared, exclusive mode, you call it as a upgrade. Or when you're converting an exclusive lock to a shared lock, you call it as a downgrade. So this is, so when the ideology is very simple, that in a concurrent execution, there exist certain problems like conflicting statements or reading on false writes. So to avoid such things, we use locking protocols. Locking protocols mainly help protect data item for that particular transaction alone, so that nobody is going to read or perform any writes over it. Only after it releases, it means only after its task is completed, it is going to release the lock, and then the data items could be read by some